let's look at an example of the trig function. So in this case, we're looking at y equals sine of x. And remember, this is the infinite wave that starts at 0, 0, makes it to 1 at pi over 2, goes back to 0 at pi, and continues, repeat. What do we have? So we have the function f of x is going to be sine of x. N is 3. We're using 3 rectangles. And this is our interval. So here's a, here's b. This is n. This is f of x. And then this is going to be the endpoints we use. We're going to use left endpoints in this one. Okay. So then what is delta x? Well, it's b minus a over n as always. But this time our b is pi, our a is pi over 4, and our n is 3. So it's a little trickier, but we can just get a common denominator. This is 4 pi over 4, right, which is pi over 3. So really it's 3 pi over 4 on top and 3 on the bottom. And then we want to simplify this a little better, so we could flip the bottom and multiply. So 3 pi over 4 times 1 over 3. 3's cancel, so pi over 4 is our delta x. Okay, so for the heights, well, first we need to identify the intervals. So we're starting at pi over 4 on the x-axis, and we're moving pi over 4 to get to the next endpoint. So the first one, you know, so if we do a plus delta x, that'll give us the end of the first interval. So this is pi over 2. And so here's how the intervals go. Pi over 4 to pi over 2. If I go another fourth, we end up at 3 pi over 4. And if I go another fourth, I end up at pi. So here are my 3 rectangles, right? From pi over 4 to pi over 2, pi over 2 to 3 pi over 4, and 3 pi over 4 to pi. And so on. Okay, so what do the heights look like? So this is the width, all the widths. So the heights, the sample points are left endpoints. So C sub 1 is the left endpoint of this, and the left endpoint is pi over 4. C sub 2 is the left endpoint of the second interval, which is pi over 2. And C sub 3 is the left endpoint of the third interval, which is 3 pi over 4. So let's plug this into our function, which is sine. So from trig, or from unit circle, or however you want to do it, sine pi over 4 is going to be square root of 2 over 2, or 1 over the square root of 2, however you like to write it. Sine of pi over 2 is 1. So I guess if we're marking these, this is square root of 2 over 2, and then up here we get to 1. And then at 3 pi over 4, we're actually back down to square root of 2 over 2. And so these are the heights we're going to use. So let's maybe draw the picture while we have it up. So we're going up to, oh yeah. So we're going up to here. This should be higher, sorry. So we're going up to here, and then across to make the rectangle. We're going up to 1, and then across to make the rectangle. And then we're going up to here, and then across to make the last rectangle. Okay, so that's pretty much it. And then let's compute the areas of these things. So we're going to have the area is equal to, let's start over, the height, square root of 2 over 2, times the width in this case is pi over 4, plus 1 times pi over 4 plus square root of 2 over 2 times pi over 4. And we're not going to get a great answer here as far as we won't be able to simplify it very much, but let's try to a little bit. So we can add all the heights and then multiply it times the width of all of the rectangles. So square root of 2 over 2 plus square root of 2 over 2, let's add those two together. So this would be 1 plus 2 square root of 2 over 2 and pi over 4. And these 2's will cancel, so really it's 1 plus the square root of 2 times pi over 4. We can't do much better than that. You might write it as pi times 1 plus the square root of 2 over 4, I guess, to make it look more like one number, but that's it. So the approximate area using these rectangles under the curve there is 1 plus the square root of 2 over 4 times pi.